Hey guys, I'm back. Let's see, this is 5-3, solving systems by substitutions. We're not going to have any graphs today. Except this first one, obviously. Yeah, this is going to be a math-heavy day today. All right, so Jackson needs a taxi ride to take him to a destination that's a little over 4 miles away. He has a graph that shows the rates for two companies. Jackson says that because the slope of the line that represents the rates for on-time cabs is less than the slope of the line that represents Speedy Cab Company, a cab ride from on-time cabs will cost less. Let's zoom in and see if he's correct, because we're figuring out which taxi service he should call. All right, so it's a little over 4 miles away, and he's saying that on-time cabs will cost less, right? So this one right here, so the blue one, right? The slope is definitely less. So over time, this will cost less. So if he's going like 6 miles, it'll definitely cost less than the other one, the orange one, right? 10 miles, definitely. But if at a little over 4 miles, which is kind of where they intersect, right? That's where the price is the same. So a little over 4 miles, the price for each of them will be a little over $10. It's like, I don't know, 10.25 or whatever, right? So technically, for this particular one, right, it doesn't matter. Because the price is the same for the distance he wants to travel. Is the same for the distance he wants to travel. So yeah, in this case, because they intersect at the point that he wants to go to, or the distance he wants to go to, the price doesn't matter because it'll be the same for either one. So I don't know. Check Yelp reviews, I guess, for which cab company is better. Yeah. Okay. So use substitution to solve a system of equation, that's SoE, with one solution. Gemma sells tickets at a fair on Saturday. She sells 800 tickets and collects a total of $7,680. How can Gemma determine the number of each type of ticket sold on Saturday? Well, we have the prices here. We have adult tickets are $13.50, and children's tickets, children for under 12 are $7.50. So the idea here, actually, hold on a second. Interruption. Oh, I can just pause it right here. Okay. So what we're going to do is we're going to write a system of linear equations to represent the situation. So we need two equations, because that's what a system of equations is, two or more, right? I'm going to say that X is the number of adult tickets, okay, and Y is the number of children's tickets. Okay. So we know the total number of tickets sold, and if we have the number of each of these, we can just say X plus Y equals 800 for that first equation. Okay, so that just represents the number of tickets sold. And then now we'll do one that represents the price. We know that the price of adult tickets is $13.50, so we can say $13.50 times the number of adult tickets, right? And then we add the $7.50 times the number of child's tickets equals the total amount collected, so $76.80. Okay, so boom, we have these two equations right here. Now, if we wanted to graph these, we could totally do that, but we don't have a graph, and honestly, with that, that's a very big number right there, and as is that, so we don't really want to mess with that graph unless you're doing it with Desmos. So solve for one of the variables. So what we're going to do here is we're going to take this equation, so X plus Y equals 800, and we're just going to solve for one of these variables. It doesn't really matter which one. Let's just solve for Y. So I'm going to subtract X over here. So we end up getting Y equals negative X plus 800. Okay, so now we have this equation right here, and then we also have this equation right here. So the idea is we're going to take this negative X plus 800, and we're actually going to substitute it in for that Y variable because this is equal to Y, okay? So we get 1350X plus 750 times, and instead of Y, we put in negative X plus 800 equals 7680. Okay, now what that does is instead of having two variables in an equation, right, that x and that y, if I could actually, right, we have two x's. So we can actually solve this because we can combine these like terms. So what we're going to do is we're going to distribute here, and we'll just use a calculator for these calculations, right? That's why we have them. Okay. So we've got 1350 x plus, actually, 750 times negative x is negative 750x, okay? And then plus 7.5 times 800, and that's what we're going to use our calculator for. So 7.5 times 800 gets us to 6,000. It's a nice even number, okay? Equals 76. Okay, so now we have these two right here, this 1350 minus 750, and we'll just use our calculator for that. All right, 13.5 minus 7.5 gets us to 6. So 6x plus 6,000 equals 7680. Now we're running out of room here a little bit, so let's just do what we can here. So we're going to solve, right? We subtract 6,000 on each side, so 7680. Oops, 7680 minus 6,000 gives us 1680. So we get to 6x equals 1680. Okay, why did I put two commas in there? Come on, Wishart. We divide by 6, and that's our x value. Okay, so 1680 divided by 6 gets us to 280. So we have the number of adult tickets sold. We have 280 adult tickets, right? So now we need to determine the number of children's tickets. So basically what we're doing is we're going to solve the other variable by taking this 280 and plugging it into one of these equations. Now, technically, you could plug this 280 into either of these equations, right, in place of that x or in place of that x and solve it. One of these equations is much easier to deal with than the other. It is this one, right? So we take this 280 and we plug it in here, so it becomes 280 plus y equals 800. And then all we have to do is subtract to get the other variable. Because remember, we need an x value and a y value, right, for these solutions. Gets us to 520, okay? So the y value is 520, right? So our solution is 280, comma, 520, right? So that's the number of adult tickets. That's the number of kids tickets, right? So adult tickets, kids tickets, children's tickets, either way, okay? So that's how you do it. It's a little complicated. It's a little bit of math, definitely, but it's not too bad, okay? So that's one solution right there, okay? So basically they crosses once. This is no solution, so these aren't going to cross, okay? Seiko takes pottery classes at 2 different studios. These are a number of hours for which Seiko's cost is the same at both studios. Write a system of equations for the situation. So we have the community pottery studio and club, which is $14 per hour, all day clay included. Then we have the private studio ceramics, which is $28 per hour plus 15 for clay. And I think, let's see, bring this coupon for half off the price advertised above. Okay. So we have two equations. So we have the community potters club. So we've got $14 per hour. So y equals 14x, right? So x is the number of hours, and y is the total cost. Okay. All right, so that's our first one. And our second one is a little more complicated because it's 15, because we have 28 per hour, and it's $15 per clay. And if you bring the coupon in, it's half off. Right? So we have a system of equations. So let's see. Use substitution to solve one of the equations for one variable. Okay, so we're going to take this. This is already in y, right? So we can take this 14x, and we can actually just sub it in to this equation, right? So we can take this 14x and just plug it directly in for that y right there. So we can set up our equation as being 14x equals 1/2 times 28x plus 15. Okay, so now we can fraction bust because we can get rid of this fraction, right? So we'll multiply by 2. Okay, on both sides. So this becomes 28x equals 28x plus 15. Okay. So you can kind of see that it's a little weird at this point, right? Because we have 28x on both sides. So we'll take this 28x over here to kind of combine our like terms. And we end up getting 0 equals 15, which is not true. So there is no solution to this, right? This would be parallel lines if you were to graph them, right? So there is not a number of hours for which Seiko's cost is the same at both studios. Okay, so use substitution to solve a system of equations with infinite solutions. Oh, wow, this is a fun one. A lot of decimals in here. So we have these two equations. So solve one of the equations for one variable. I'm going to solve this one because it looks a little bit easier because we can just deal with that x, right? So we've got this negative 2y minus x equals negative 84.91. So we're going to add 2y over. Okay, so we're at, actually I'm going to bring it over here. I didn't leave a lot of room here. 2y equals, nope, negative x equals 2y minus 84.91. We'll divide by negative 1. So basically just changes all the terms here, right? So this becomes negative 2y plus, not equals, sorry, plus 84.91, okay? Yeah, so let's see. Let me make sure I got that right. Add the 2y over, yep. And then change the signs by dividing by that negative. Yes, so substitute this solution into the other equation. Now this is a lot of decimals, so it's kind of a pain, right? We just gotta be aware. So right, so we're gonna take this part right here, and we're gonna substitute it into that x right there, okay? So it becomes 3 times negative 2y plus 84.91 plus 6y equals 254.73. Okay, so now we are, I should have done that on that blue color. Come on. All right, so now we're going to distribute here. Okay, so that's negative 6y, and the 3 times 84.91. This is where you're going to see how this works out. Okay, so 3 times 84.91. Oh, look at that. Okay, 254.73. Plus 6y equals 254.73. Okay, so negative 6y and 6y are going to cancel. So it's 254.73 equals 254.73. So it's infinite solutions on that. Okay, it's the same line. Okay, now we're going to put this in our notebook. Let's see here. It has been 5 days since I've been here, so hold on. Okay. This is going to go on page 44. 45 actually for me. Okay, so let's see, let's go page 45. Yeah, I'll skip because there's a reference page there. Okay, so 45, this is 5-3, solving systems of equations by substitution. Substitution. Always have to think about how to spell that. Okay, guys, there you go. Thank you.